ठीक है, wait for few minutes that all the people get admitted. So let's start. So we have been talking about the Lagrange multiplier method to find out maxima and minima that is subjected to some constraint. Okay, in case that function is subjected to a constraint. So now we will continue with that and we will try to do some problems based on that. Okay. So let me first start with an example that you have to find maximum value of a function, and that function is given by x to the power m, y to the power n, z to the power p, subjected to constraint x plus y plus z equal to. All right. Find the maximum value of a function x to the power m, y to the power n, z to the power p, subjected to constraint this. Problem is clear? So now,
Yes, sir.
let us try to use Lagrange method to solve this problem. In order to that, let me consider that x, y, f is equal to x to the power m, y to the power n, z to the power p. All right. And g is equal to x plus y plus z minus a, or equal to a. All right. Or x plus y plus z, in fact, not a. X plus y plus z. ठीक है? Is it okay?
Yes, sir.
Yes, sir.
All right. So now I want to find out. I want to find out or equal to a भी तो दिया हुआ है ना, equal to a constant. तो equal to a constant है. Constant, that is k. A. Okay, in this case. Anyways. What I was going to do. Right. So now, now, please, somebody's microphone is humming in my ears. Who has switched on his microphone?
Manish,
Please, sir.
off it.
ऑफ है मेरा.
हाँ, अभी ठीक है. Okay. So now we have to do this problem. How do we do it? Let us see. So first of all, we have to find out gradient of f. Okay. Gradient of f is fx dx plus fy dy plus fz dz. Okay. Or I hope it is clear.
Yes, sir.
Delta f is equal to this, right?
Yes,
So
sir.
now fx will be, differentiate this with respect to x. So m x to the power m minus 1 and z to the power 1. Fy is equal to n x to the power m y to the power n minus 1 z to the power p, and fz is equal to p x to the power m y to the power n z to the power. Is it okay?
Yes, sir.
And similarly, we have to find out gx also. So I will write down as capital G. Doesn't matter. Gx is equal to 1, gy is equal to 1, and gz is equal to 1. Is it okay?
Yes,
If I
sir.
differentiate with respect to x, y, and z respectively, this is what we will get.
Yes, sir.
And then from that, Lagrange's method delta f plus lambda delta g is equal to 0. This is what the method is. Method tells us.
Yes.
Is it or not? So delta f is m x to the power m minus 1 y to the power n z to the power p into dx plus n x to the power n y to the power n minus 1 z to the power p dy plus p x to the power n y to the power n z to the power p minus n dz plus lambda into dx plus dy plus dz because their multiples are 1 1 1 1. Okay, so can I write down it like this?
Yes, sir.
All right. So once we have got this, then then we can take these together. So x to the power m minus 1, y to the power n, z to the power p plus lambda is equal to 0. As I told you that because these are the functions, individual functions of x, y, and z only, then this can be 0 only if individually they are equal to 0. Okay. So multiple of dx is this one, this has to be 0, and similarly multiple of dy and multiple of dz. Is it or not? So n x to the power m, y to the power n minus 1, z to the power p plus lambda is equal to 0, and p x to the power m, y to the power n, z to the power p minus 1 plus lambda is equal to 0. Is it okay?
Yes, sir.
All right. All right. So now from this x will be equal to minus m x to the power m y to the power n z to the power p by lambda. Can I write down it like this? From this,
Yes, sir.
or I can write down x equal to minus m into f by lambda because this is what the original function is. F we had considered. Is it or not?
Yes, sir.
Yes, sir.
Similarly, y will be equal to minus nf by lambda and z is equal to minus pf by lambda. Okay? So we have found out x, y, and z. But lambda is yet to be found out. If we find out lambda, then we can solve this equation and we can find out concretely x, y, and z. Okay. So how can we find out lambda? For lambda, the equation is g is equal to constant. Is it or not?
Yes, sir.
And this is means we put these values over here. So minus mf. So I can write down simply like this: minus m plus n plus p into f by lambda is equal to. Can I write down it like this?
Yes, sir.
And from this lambda can be written as minus m plus n plus p f by a. Huh?
Yes, sir.
And from that, if I put values of lambda in this, so x, y, and z can be found out. So what x, y, and z will come out to be then? X will come out to be m by m plus n plus p. Huh? ठीक है ना?
Yes, sir. Sir.
Y is equal to a n by m plus n plus p, and z is equal to a p by m plus n. I hope it is clear.
Yes, sir.
Okay, so once we have found out this x, y, z, so these are our, what should I say? These are our stationary points,
Critical point.
critical point, right? And once we have found out this critical point, let us plug into the function. And because already we are saying that it is maximum, so we don't have to go through all those steps of RT minus S square greater than 0, looking for that. Because it is already saying that it has to be maximum. So it means it is maximum at this. So the function will be x to the power n means am to the power m plus n plus p to the power m into an by m plus n plus p to the power n and ap by m plus n plus p to the power p, and so we get f is equal to m to the power m, n to the power n, p to the power p, a to the power m plus n plus p by m plus n plus p to the power m plus n plus. Okay?
Yes, sir.
Yes, sir.
So this is what the maximum value of function. ठीक है?
Yes, sir.
ऑलराइट, एक सवाल और करते हैं थोड़ा. करें?
Yes, sir.
Okay. So suppose we have a closed rectangular box. Has width okay, has width x and length twice of x, means double of length is double of width. ठीक है, बक्सा लंबा है, ये बड़ा है, 2x है, and this is x. Is it okay?
Yes, sir.
Okay. And has constant volume. That volume is V. Okay. So determine the dimensions of the box. Requiring least surface area. ठीक है? This is what our problem is. ठीक है? Is it or not?
Yes, sir.
Yes, sir.
Okay. So now, how many lengths we have now?
2.
2 is given and one more must be there, some Z or something like that.
Yes, sir.
Height. Height is required. No, height is not given over here. So that we will have to assume. So now let us do this problem. कैसे करेंगे? First of all, इसका वॉल्यूम क्या, इसका लेंथ क्या होगा?
X.
2x. विड्थ है x और हाइट है मान लो z. Is it okay?
Yes, sir. Yes, sir.
या या y मान लेते हैं, बेटर होगा क्योंकि z की जरूरत ही नहीं पड़ेगी y. ठीक है? So these are our this thing. So what will be the volume? x into 2x into 1, है ना? इतना ही होगा ना इसका volume?
Yes, sir.
That is equal to 2x square. Okay? Alright. So now what we need to do? Alright. So the total surface area is how much? 2 into 2x into x. Okay?
Yes, sir.
Then 2 into
X
2x
into
into
Y.
y, 2x into y, है ना? Plus
Yes, sir.
2 into xy.
x into y.
ठीक है?
Yes, sir.
x into y, y into z, z into x. ठीक है? Clear हो गया सारा? Right. So now this will be equal to 4x square plus 6xy. So let me consider that this is my function s, which is dependent on x and y. This is my function. Okay? What about the next thing? Condition is given x square is equal to v by 2. That is constant. It is told that volume is constant. So it means this is also constant. V by 2 is also constant. Eh? X square into y is equal to v by 2. Doesn't matter. So now this is the condition. So means our function will become 4x square plus 6x, ठीक है, y plus lambda into x square y minus v by 2 is equal to 0. I can write down it like this. And now what I have to do, I have to take the derivative of this. So derivative of this will be what? fx. Fx will be 8x plus 6y plus 2 lambda xy equal to 0, and fy is equal to 6x plus lambda x square is equal to 0. एक ही बात है जैसे हम लोग करते हैं डेल्टा जी डेल्टा एफ प्लस लैम्डा इनटू डेल्टा जी, यही कर रहे हैं ना हम इसको.
Yes, sir.
Same thing. Okay. So that is what we did, and we found out this, and from this, what we can find out? We can find out lambda is equal to minus 6 by x, and so x will become minus 6 by lambda. Okay. Now we can substitute in the equation. That equation was what? 4x square plus 6xy plus x square lambda into x square y minus b by 2 equal to 0. So इसमें put कर दें इसमें. So that will be minus 48 by lambda plus 6y minus 12y is equal to 0. And from this, I can find out y is equal to minus 8 by lambda. So we have found out x, we have found out y, but we have yet to find out lambda. And once we plug lambda over here, we will be able to determine accurately what is x and what is y. So in order to find out lambda, what we need to do? we need to put it in this equation. X square y is equal to v by. Is it or not?
Yes, sir.
Alright. So
Yes,
let us put it in this equation. So this square means 36 by lambda square into minus 8 by lambda is equal to v by 2. ठीक है?
Yes, sir.
So lambda
Yes.
is equal to minus this, if we solve 576 by v to the power 1 by 3, क्योंकि यहाँ पर lambda is cube, so that will be 1 by 3. Okay, so x will become equal to, now you can put back in this one and you can find out x and y. तो x and y क्या आ जाएगा? X will be equal to 6 by 576 by b to the power 1 by 3, है ना? माइनस माइनस कैंसिल हो जाएंगे. भाई किसी का ये साउंड आ रहा है, प्लीज चेक योर साउंड. So that will come out to be equal to, if we solve it, it will come out to be 3b by 8 to the power 1 by 3. And similarly, we can find out y. Y will come out to be equal to, y will come out to be equal to 8b by 9 to the power 1 by 3. Same way we can find out. So your surface area will be, so these are the points you have got, stationary points, x and y. Is it or not?
Yes, sir.
And
Yes,
so
sir.
you put back in that equation. So s will be equal to 4x square plus 6xy. So that will be your 4 into 3b by 8 to the power 2 by 3 plus 6 into 3b by 8 to the power 1 by 3 and 8b by 9. Alright, so further simplification can be done, and if you further simplify it, it will come out to be 243 b squared to the power. So this is how the Lagrange's method works. I hope it is clear to you all.
Yes, sir.
Yes, sir.
yes, sir.
Alright, so now I ask you to solve a problem. Has everybody done this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Problem is that you have to find out shortest distance between the origin and the surface x, y, z square.
XYZ square is equal to
2. Clear? This you have to find out. Find out.
Sir,
Ah,
sir, answer 2.
answer 2. Very good. How did you find out?
Sir, first x, y, z square equals to 2. Distance is x minus 0, y minus 0, z minus 0. So, square सर डिस्टेंस फॉर्मूला से डिस्टेंस निकाला सर फिर मैंने एक्स वाई को एक तरफ लेके जेड को एलिमिनेट किया सर फिर एफ ऑफ एक्स डी स्क्वायर इक्वल्स टू एक्स स्क्वायर प्लस वाई स्क्वायर प्लस 1 by एक्स वाई अच्छा 2 by एक्स वाई फिर एफ ऑफ एक्स को 0 किया एक्स क्यूब वाई माइनस 1 by एक्स स्क्वायर वाई इक्वल्स टू 0 फिर रीअरेंज किया सॉल्यूशन निकाला x इक्वल्स टू प्लस माइनस वाई विच इज प्लस माइनस 1 2 हमें विल गेट 2 पॉइंट्स सर x इक्वल्स टू 1 comma 1 x equals to minus 1 comma 1 substitute back in the equation z की वैल्यू आएगा सर so after taking z की वैल्यू फिर fx fy fz सॉल्व किया सर फिर z की वैल्यू √2 था so minimum distance फार्मूला से 1 square plus 1 square plus 2 square
करेक्ट
√2
करेक्ट
square
ठीक है, समझ में आया किसी को?
नहीं सर, नहीं आया।
No, sir.
नो सर।
नहीं आया समझ में?
Yes, sir.
यस सर और नो सर क्या?
तो फर्स्ट पार्ट तो समझ में आ गया। उन्होंने शॉर्टेस्ट डिस्टेंस बिटवीन 0 0 ओरिजिन से लेकर के डिस्टेंस तो निकाला, उसके बाद वो डिफरेंशिएटिंग पार्ट वो थोड़ा
चलो, what he is saying he has done is कि जो डिस्टेंस है वो है रूट ओवर एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर, किसी पॉइंट की, मान लिया एक्स वाई जेड कोई पॉइंट है सरफेस पर, ठीक है? और हमको कंडीशन तो दी हुई है ही, दिस इज इक्वल टू 2 है, तो जेड स्क्वायर इज इक्वल टू 2 बाई एक्स वाई। इनका कहना है कि डी स्क्वायर इज इक्वल टू एक्स स्क्वायर प्लस वाई स्क्वायर प्लस ट्वाइस ऑफ एक्स वाई। यहाँ जेड स्क्वायर की जगह पर ये रख दिया। इज इट ओके?
यस
एंड दिस यू कंसीडर अ फंक्शन। डी किस पर डिपेंड कर रहा है? एक्स और वाई पर, राइट? So you can find out fx. Fx is 2 minus 2 by x square y. Fy is equal to 2y minus 2 by xy square. This is equal to 0. This is equal to 0. So it means from this we found out xy into x square minus y square is equal to 0. ठीक है कालिदास?
Yes sir, x equals to 0 cannot be a solution.
हाँ,
डिनोमिनेटर में है।
हाँ, y भी नहीं हो सकता है।
हाँ, y भी नहीं हो सकता सर। So we'll get only one solution.
Only one solution and that is y is equal to plus minus x or x equal to plus minus y, जो भी लिखना चाहो। Is it okay?
Yes, sir.
Right? So now one can find out from this कि x is equal to what? तो हम इसको ऐसे भी लिख सकते हैं x square y, sorry x cube y is equal to 1 और x y cube is equal to 1. Can we write down it like this?
Yes, sir.
और इसमें पुट कर दें तो x to the power 4 is equal to 1. So या तो 1 1 आएगा, है ना, या -1 1 आएगा। Is it okay? जो x है वही y है, यदि x प्लस है तो y भी प्लस है, राइट?
यस सर।
Yes, sir.
राइट। सो ये आएगा। अब इसको इसने वापस पुट कर दिया इसमें सेम इक्वेशन में, तो अब हमारे पास कोऑर्डिनेट मिल गए 1 1 और z का
√2
यहाँ से, हाँ √2 यहाँ से मिल गया हमको, तो √2 मिला 1, है ना, एक पॉइंट तो ये मिल गया, और दूसरा पॉइंट क्या मिल गया, -1 और अगेन √2, यहाँ से तो √2 ही आएगा, -1 भी रखेंगे तो -1 into -1 अगेन प्लस, सो √2 आएगा. इज इट ओके?
Yes.
Yes, sir.
Yes, sir.
तो बस, तो डिस्टेंस यही है ना, डिस्टेंस इज इक्वल टू √1 स्क्वायर प्लस 1 स्क्वायर. एक्स वाई जेड मिल गया तो हम पुट कर दे, ये रखें या ये रखें, बात एक ही है, कोई फर्क पड़ेगा इससे?
No, sir.
दैट इज इक्वल टू, क्लियर?
Yes, sir.
Sir.
So we have finished our chapter number 1. Okay, we have finished our chapter number 1. Anybody having any kind of problem, you can tell me. कोई प्रॉब्लम?
No, sir.
No, sir.
No, na? So we will start new topic, that is integral calculus. So what is an integral calculus actually? What is integration?
Sir, curve tracing is not in our part.
Not curve tracing, that is not in our part.
Sir, that is difficult topic, sir.
Which one?
Integral calculus, very difficult, sir.
No, it is not difficult. What is an integration, by the way?
Area under the
Summing up of
Area under curve, sir.
integration of the
We will see. We are here to learn some complex things as well, not the simple things. I don't think that these topics which we have learned so far are that easy, are they? But
sir,
we have
differential
made-
calculus is easy. We can understand something, sir. Integral calculus is difficult. Sir.
Okay, no issues. So what is an integral calculus actually? What do you mean by integration? It is if you know rate of change of a function. If you know it, then we can obtain function itself by integration. What did I say? That if I know rate of change of a function, then we can obtain function itself by integration. So basically this is what we are going to do in this integral calculus. Now where is it? It is useful if we want to find out, let us say, area of the surface. Or we are trying to find out volume of the volume, or we are trying to find out moment of inertia. What is moment of inertia, by the way?
I square R.
I square r both are
Sir, MR square.
mr square. Physically what does it mean?
सर मतलब कोई सर जैसे बॉल है तो वो कितने एरिया में डिस्ट्रीब्यूटेड है
मोमेंट ऑफ इनर्शिया ये होता है.
सर मोमेंट ऑफ इनर्शिया होता है इस सिंगल पार्टिकल का मास इनटू डिस्टेंस फ्रॉम फिक्स्ड लाइन व्हिच इज कॉल्ड एक्सिस का होल स्क्वायर.
ओके, ये तो मैथमेटिकली हुआ ना. और फिक्स लाइन क्या है?
वो एक्सिस ऑफ रोटेशन है.
एक्सिस ऑफ रोटेशन है. ठीक है, तो इसका मतलब ये कहाँ यूज होता होगा? मोमेंट ऑफ इनर्शिया कहाँ आता होगा?
रोटेशनल में
Rotation.
रोटेशनल की जहाँ टॉपिक
रोटेशनल मैकेनिक्स में जहाँ भी रोटेशन होगा वहाँ मोमेंट ऑफ इनर्शिया यूज होगा,
हाँ
है?
सर
तो व्हाट
हाँ
इज इनर्शिया?
The tendency
State of the
of
body in rest.
object to maintain its position.
ओके, सो मोमेंट ऑफ इनर्शिया क्या होगा? रोटेशनल मोशन में यही काम जो कर रहा है वो मोमेंट ऑफ इनर्शिया। जैसे हम फैन को ऑन करते हैं, फैन इमीडिएटली ऑन हो जाता है क्या?
नहीं सर।
नहीं सर
कुछ टाइम लगता है ना उसको, है? व्हाट इज दैट? इट डजंट वांट टू चेंज इट्स पोजीशन।
सर टॉर्क लग
नहीं, it just doesn't want to change its position, but it has to. Okay, that's a separate issue because you are applying kind of force in order to rotate it. So whatever is the role of mass in a translational motion, okay, mass is resisting the motion, isn't it? That inertia is resisting the motion. So here also it is the same thing, that is called inertia, and that is moment of inertia. Rotational motion में वो same चीज moment of inertia. And you might have studied that how one can calculate obtain moment of inertia, right?
Yes, sir.
Of different bodies.
Yes, sir.
All right, so that is what we have done so far. So now we will do integral calculus, and in this we are going to learn in particularly about those functions which are having whose powers are high. So if they are having high powers, then we need to reduce this formula into a known form, and there we will use integration by parts. What is integration by parts?
Sir,
What is
first function
integration?
into integration of second function minus integration of
So this is equal to, sorry, UB
yes sir
minus BD. Okay, isn't it? First function as such, integration of second function minus integration of second function and differentiation of the first function. All right, this is what the integration of by parts is. So we will be seeing such kind of reduction formula. Now we will confine ourselves to some trigonometry function. Like sine to the power nx, cos to the power nx. We want to find out integration of such kind of integrations. Okay, so we have to सर मैं भी थोड़ी देर में ज्वाइन करता हूँ। मैंने आपको मेल भेजा था कि क्लास के बाद में। So such kind of trigonometry functions we will be trying to find out what we call as reduction formula, so that we can bring it in such a form that easily one can solve them. Okay, so that is our topic. So we will start from the next class.
Yes, sir.
All right, आज छोड़ देते हैं।
Okay, sir.
तो
Okay,
कल करेंगे क्लास।
हाँ
Yes,
सर।
Yes, sir.
yes sir
ओके सर
All right, ठीक है, कल करते हैं। I'll give the time. तुम लोग कब फ्री हो?
Sir, evening.
Morning, sir.
सुबह
हम लोग फ्री है।
सर
सर
आप जब गए तब सर।
अब आप लोगों का टाइम मतलब क्लास से क्लैश नहीं करना चाहिए, दैट इज व्हाट आई मीन।
9:30
मॉर्निंग
Morning, sir.
morning sir
मॉर्निंग में क्लास है आपकी?
No, sir.
नहीं सर,
नो सर नहीं है।
कल नहीं है
कब है क्लास?
संडे को
सर कल नहीं है, मंडे को
कोई भी क्लास नहीं है सर।
तो कभी भी ले सकते हैं ना कल?
हाँ
yes
तो ठीक है, मैं भेज दूंगा लिंक।
Okay,
जब मुझे टाइम मिलेगा आई विल सेंड यू। Okay.
Okay, sir.
Goodbye, sir.
Goodbye.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Good day, sir.
Thank you, sir.
Good day.